Hello everyone. Today we are going to discuss about the capabilities of LLM along with embeddings. So LLMs are pre-trained models where it has knowledge based on the training data. Whereas if you want to make the LLM aware of your documents which is there in your local repository, LLMs will not have that understanding. So with the help of embeddings, so what you can do is you can make the LLM aware of what is there with you. So we can very well fine tune the LLM model, but that is cost impacting, time consuming, power impacting, and so on. So to make the models aware of whatever the documents that you have, and if you want to make the LLMs to respond in such a way that it should read the contents from your documents and give some customized output, you can make use of embeddings instead of fine tuning. So that is the capabilities of LLM with embeddings on a high level. So this is the project that we are going to discuss today. If you see here, I have given you a short overview on semantic search and how it can be used for custom applications and contextual understanding based on the given content. The features with respect to embeddings, and this contains a short code as well, which makes use of llama-index to showcase the capabilities of embeddings along with ChromaDB as vector storage. So installation, you can git clone the project and then directly go to Python settings.py for execution. So it will start a small chatbot which is making use of Gradio, and it starts the Chroma vector DB as well along with the fast API application which access the API for calling the LLM models along with embeddings. So this is the YouTube link. You can actually go into it and then get the live demo there. And this is the project structure. You can very well download the code and see how it is designed. And this is an open source project. You can make use of this project for your learning, as well as if you want to implement something, you can very well use this. And if you have any doubts or clarifications, or if you want to contribute anything with respect to GenAI advancements, you can get in touch with me. You can see the mail ID here, and in the video below I am giving my LinkedIn as well as my GitHub profile. So please contact for any clarifications. Okay, so I'm directly jumping into the project which is there in my Eclipse. So this is the embedding demo. So whatever I have showcased in the documentation, I want to explain in a live manner. So this is the settings file which I have discussed about. So here, if you see, I have used two sub-processors. One is for ChromaDB. So ChromaDB is one of the vector DB that we have. We have FIS, we have Postgre, we have a lot of vector DBs available. So for this demo, I'm using ChromaDB. I'm also using llama-index as the framework for fetching the output from Chroma database. And I'm using a Gradio chatbot for user interaction. And I'm starting this fast API service using UVCon. So fast API service access the REST endpoint where we have the LLMs, we have the embedding models, we have the Chroma DB interfaces as well, where the input from chatbot gets passed to this API service, and then it process the output based on the user input from the context. So to start it, I'm just running this as a Python file. So it invokes the Chroma DB as well as the bot interface along with this fast API service. So if you see here, you can see the endpoint and the URL, IP and port for fast API service, for Gradio chatbot, for ChromaDB. So let's go into this Gradio chatbot. So this is the chatbot, quick chatbot that we have here. So this is the code for Gradio chatbot. This is available in the repository. You can very well use it for demo purposes. And this is the path for the fast API service. Okay, so we can go with docs. So this opens the Swagger documentation where you can see the endpoints. Oops, I missed the colon. Okay. So this workflow is tightly coupled with llama-index. So before executing the code, I just want to showcase. So we have these requirements present. I think I have updated the latest requirements in my GitHub repository. You can make use of that. And config properties contains the LLM embedding configurations and vector database that also you can see in the repository. And this is the bot interface, which is the graded chatbot, which I have discussed. And this is the starting file of the API service. So if you see, this is the endpoint. So this is getting triggered from the bot interface. If you see here, this is the endpoint. So from there, it is taking the user input and chat history from the Gradio chatbot, and then it is invoking the user workflow. If you go inside it, there is a method called embedded query workflow, where it is passing the user history input and chat history. And before looking into it, if you see here, there are few methods available. So I'm hosting this ChromaDB as a service. And here, if you see, there is something called create embedding. So when I give some user input to the chatbot, the LLM gets invoked, and then it will give response based on the learnings it has, based on the training that it had. But if you want to make the LLM aware of certain details instead of retraining, fine tuning, I told we can give the document in the form of embeddings, right? So here what I'm going to do is I'm going to upload a document with respect to k-means clustering, and then what happens is the input will come here, and then in the file processor it is taking the file format of document and text. At this point of time, you can actually extend it to any file format. So inside that, I am actually converting it to embedding format. So if you see here, I'm using a component called pipe and doc. So pipe and doc, what it does is it will convert the file format from one to another. Say for example, if you want to convert from docx to text, it will do it. The reason behind using this is I have a documentation which is nothing but k-means clustering, as I explained earlier. So it has text content as well as images. If you see here, there are certain images present. So vector embeddings are text embedding models. So you can convert the text into vector. So what happens is if you are giving some text, it will be converted into number format so that the system can understand very well. So each word will be converted into based on its model's dimensions, it will be converted into vectors. But the images, we are not using any OCR here. We are actually storing the images as is. So in the chatbot, whenever user asks some questions with respect to some contents, and if the contents contain some images, what it happens is it will render the vector contents into text, and then it will extract the image as is. So for that, to perform all these operations, for embeddings, we need to convert this text into vector, and then the image needs to be stored somewhere. So PyPandoc actually does everything at one shot. So if I give the input file which contains the k-means clustering data along with images, what it happens is it will convert the file content to HTML format, and then the images or objects which are present in the document will be extracted to a different directory. And in the output content, it will actually make a reference to these images, and then give the referenced link in the output file as well. So whenever I do the embeddings for the newly generated file, it will have the reference path as well. So whenever when we ask some user when we ask the questions in the chatbot, it will be able to extract the contents as well as the images completely. So that is the reason why we are using PyPanda. If you have a more sophisticated component to convert the file from one format to another, please drop a message or comment in the video so that I can also make use of that. So this is about PyPandoc, and once everything is done, I have the new file format here, and then I'm making use of the data reader from llama-index, and then converting the entire content into vector form. and then storing it in the vector database, which is nothing but ChromaDB in our case. So this is a batch process which we are doing. Coming to embedded workflow. So once the embeddings are created, it will be in the form of numbers in ChromaDB. So when user is asking a generic question, if the contents are not present in embeddings, it will respond based on the knowledge it has based on the pre-trained contents in the LLM itself. But if there are certain questions which are relevant to the documents, what happens is it will convert the question into a vector, and then it will try to match the vector with the vectors which are present in the ChromaDB. And if it gets matched, it is based on the question similarity. There are videos available in YouTube on how the vector embeddings matched and what is question similarity and all those stuffs. You can check all those things in the YouTube video itself. And based on the question similarity, it will extract the relevant content, and LLM on top of it, it will interpret the extracted content and give a response back to the user based on the user question. So this is how the entire workflow occurs. So if you see here, I have the buffer memory where I am storing the chat history, and we have a system prompt as well. If you want to set it, you can set it. And I have made the chat mode as context so that it can understand the previous conversation as well. And then this index is from the ChromaDB. So once everything gets ready, what happens is I am passing the user input to this chat engine, so it will be interpreted. If the contents are present in the document, it will extract it and then interpret and then give the response. But if it is not present based on the pre-trained data in the LLM, it will give a generic response to this. So this is how the workflow goes on, and this response is given back to the chatbot itself through the router that I have showcased here. So this is the complete workflow. So to showcase this, so first there is an endpoint. There are many endpoints present. You can check it at later point. So for this demo, if you see, there is an endpoint called create embeddings. This is the Swagger UI, which is coming by default in Fast API. So here, what I'm doing, I'm giving a module name as demo. So this is used inside our workflow. You can very well customize it as well. So I'm just uploading k-means clustering and execute it. So what happens is, so pipeline comes into picture, we'll extract the objects, keep it in a separate directory, and then make the contents as vectors in ChromaDB. So if you see here, embedded files, so this is the k-means clustering document, this is the actual document, and this is the converted document in the form of text. This is HTML content, and if you see here, the images are converted into some sources, nothing but the image path here. So this path is nothing but the path which is present here. So whatever the images that we have in the document is actually represented like this in the same name of the document. So now this file is used for embedding. So if you see the ChromaDB contents, you can see some data present here. So this contains embedded components. This can be opened using SQLite if you have. There you can see the embedded contents as well, and clear context contents as well. So that's it. So now I'm going back to the UI and I'm just saying hi. So it'll give a response. If we ask a generic question, who is the PM of India? So based on the pre-trained data of the LLM, it is responding like this. But when I say something with respect to the document, it can give response appropriately. Say for example, okay, what is step 1? I just ask what is step 1, because it is nowhere present in the LLM. It is step 1. So this will be converted into vector, and then this will be matched with the vector embeddings which is present in ChromaDB, and based on the question similarity, it will extract the content, and the LLM will interpret it and give the response like this. If you see the document here, So it is talking about importing the necessary libraries. So here also it is giving the same context, importing the necessary libraries and things like that, right? So I will ask something about step 1. What is the output of step 1? I expect a diagram here. What is the output of step 1? And show it. What is the output of step 1 and show it? So I'm expecting an image, but does not produce any visible result because it is simply importing the okay, so and so. Oh, I think this is step 2. Sorry, I made a mistake. What is the output of step 2? Oh, this itself is asking, would you like me to explain? I didn't see that. So it is giving the output is a scattered plot. It is stating that it is a scattered plot. Can you show the plot? Let's see what it is coming up with. Can directly display plot images here. So I think it is not able to extract the image here. State explicitly telling that give the image. Okay, I think it is getting confused with the context in a different way. Okay, we have an image in step 9. Can you get the output of step 9? Let's see whether it is able to render the image. Yes, it is able to render the image, but I think it is because of the AI issue. No, the image is not loading. So let me copy the image address. It's blocked. Okay, so it can. Sorry for that. So it can able to give the image, but I think in Gradio it is getting blocked. So basically, if you see here, it is giving the appropriate content, the iteration and the stuff, and it is explaining the description as well, and then it is giving the image, but it is not getting rendered. So this is how we can make use of embeddings if you don't have the privilege or the capability to fine-tune the model, since it consumes a lot of resources. We can make use of embeddings to make the LLM aware of our document so that it can respond appropriately. But if the user input doesn't match with the vector embeddings, then it may not able to extract the content. So we may need to rewrite the user input in such a way that it should be able to extract the contents from the embedding. So these are all advanced concepts like query rewriting and so on with respect to embeddings that we can see in a different discussion. So on a high level, this is how we are making use of embeddings to make the capabilities of LLM much better for our business purpose. So here we are using fast API service, llama-index, ChromaDB for vector storage, and a simple chatbot interface using Radio. And we are configuring LLM Azure OpenAI GPT-4o, and we have the text embeddings for vector embeddings, and everything is configured if you have the subscription present. You can also use different models as well. There are a lot of open source models available, so that also has the capability to do all these stuff what I explained so far. So that's it from my end. So this is how we are making use of embeddings along with LLM. If you have any questions, if you want to contribute anything, you can very well contact in the mail ID present in the GitHub repository, or you can check the below link where I have given the link for GitHub as well as my LinkedIn. Any comments you want to give, just share it. If you want any assistance, just drop a message. I will bring you back. Thank you and have a nice day.